So you guys, last week we looked at exponential functions and using those to look at interest. But before that we talked about just what makes an exponential function. And one of the things I told you was that exponential functions have an inverse. So today we're going to talk about that inverse, and that inverse is called a logarithm. So we had our exponential functions where our x was a power, so it was a to the x. Today we're going to look at the opposite of exponential functions, and those are called logarithms. So we have a standard form just like we did for exponential functions, and our standard form is f of x equals log base a of x. And that's how we say that statement, log base a of x. So this a right here, that's going to be a number, and we call that little number the base. So a is the base, whatever this number is, we call it the base, and then whatever is in parentheses, whether it's an x, whether it's a number, whether it's several numbers and variables together, whatever's in the parentheses of the logarithm is called the argument. So those are some words I'm going to use to refer to the parts of a logarithm, but when we say a logarithm, we say log base a, whatever that number is, of whatever's in parentheses. And we have some rules for logarithms the same way we had rules for exponential functions. So we've got 3 rules to look at. The first rule is that our argument has to be greater than 0. So whatever's in parentheses inside of that logarithm has to be positive. It cannot be 0 or less than 0. It has to be greater than 0. Next, we have to have our base be greater than 0. So our base also has to be positive. And then one more rule, the base cannot equal 1. So the base has to be a positive number, but not 1. It could be a positive number like 1/2. It could be a fraction, but it can't be 0 or negative, and it can't be the number 1. Any other number works. So any fractions work, and then anything greater than 1 like 18 would work as well. So those are our rules for logarithms. So we're going to look at a couple of examples and decide whether or not this example would count as a logarithm based on our rules. So the first example we're going to look at is the function f of x equals log base 3 of negative 2. So log base 3 of negative 2. And we're going to go through our 3 rules and figure out whether this would be a logarithmic function or not, whether it's allowed. So rule 1 says the argument has to be greater than 0. So if we look to figure out where the argument is what's in parentheses. So in our parentheses we have a negative 2. Well, negative 2 is not greater than 0. Negative 2 is less than 0. Because of that, this function is not a logarithmic function. It would not work. In fact, if you tried to type this into a calculator, it would give you a message saying error because we can't have negative 2 as our argument. All right, so our second example, let's look at f of x equals log base negative 3 of 5. All right, so log base negative 3 of 5. So looking at this function, going through our rules, our first rule is that our argument has to be greater than 0. Well, in this case, our argument, which is what's in parentheses, is 5, and 5 is greater than 0. So we're good for rule number 1. Rule number 2 says the base has to be greater than 0. So looking at our base, that base is the little number after the logarithm. So in this case, our base is negative 3. So we would say this log base negative 3 of 5. So negative 3 is the base. Negative 3 is not greater than 0. Negative 3 is less than 0. So because of that, this function is not logarithmic. So even though we see that log in the function, it's not going to be a logarithmic function because it doesn't follow our rules. Just like the last one, if you tried to type this in a calculator, you would get an error message. All right, and then finally, let's look at f of x equals log base 6 of 5x squared. So looking at this function, first we check to see if our argument is greater than 0. So we've got 5x squared in the parentheses. So 5x squared is our argument. And 5x squared is positive. There's not a negative in here, so we're okay right now. And the x can kind of make it a little tricky to work with, but just the way this is written, that's okay. Next, our base has to be greater than 0. So the base is that little number after the log. So this is log base 6. And 6 is a positive number. It's greater than 0. So we meet rule number 2. And rule number 3 says the base cannot equal 1. Well, 6 is not equal to 1, so we're good there. So this last function would be considered a logarithmic function. All right, so that's how to determine if a function is logarithmic or not. Next, we're going to look at how to convert between logarithms and exponential functions. So I'm going to erase what we've got here. And we're going to look at going back and forth between logarithmic and exponential functions. So I'm going to start with something that's exponential. I'm going to start with 2 cubed equals 8, which is a true statement. 2 cubed is 8. 2 times 2 times 2 equals 8. Now this is exponential because we have something with an exponent, so this is an exponential form. We want to convert it from exponential form to something that has a logarithm. We're just trying to rewrite this in a different way. So to do that, to go from exponential form to logarithmic form, we're going to start at what we called the base when we talked about exponential form. And the base was the number that has an exponent. So we're going to start with the 2. And that's the first number we write when we write it as a log. So the base in exponential form is the same as the base in logarithmic form. So we write log base 2. So that's the little number after the log. Next, in our log loop, we loop around to the other side of the equal sign. So we start at the base, we go to the other side of the equal sign, and that's the next number we write in our logarithm. So in a logarithm, after the base, we write the argument. So 8 would go in parentheses. And then we loop back around to the last number, which is our exponent here. And when we loop back around to the other side of the equal sign, we write equals and then the number we land on. So log base 2 of 8 equals 3. So that was an example with numbers. Our general rule, though, is going to be that if we have a to the x equals y, then we use our log loop to rewrite it as a logarithm. So we'll start at the base, which is a, so we write log base a. So the base is the same in both forms. And then we loop around to the other side of the equal sign. So we loop around to the y, so log base a of y, that's what goes in our argument. And then we loop back around to the other side of the equal sign and finish with the x. So log base a of y equals x. So that's the rule just with variables. So anytime you have anything in either of these forms, you can go back and forth between the two different forms. And you can either practice your loop, or if you write down this rule, then when you see something in either one of these forms, you just have to identify which numbers go with which variables and rewrite it. So this goes from exponential to logarithmic form. We can do the same thing the opposite direction. So following the same rule, if we start with log base a of y equals x, we can use that same loop, which we call the log loop, to get back to exponential form. So we always start at the base, and that's the first number we write in our exponential form. That's the base in exponential form. So we write an a. Then we loop around to the other side of the equal sign. And in exponential form, because that's what we're trying to get to, the next number after the base is the exponent. So x becomes the exponent. And then finally, we loop back around across the equal sign, and this time we're going to finish at the argument. So go to that last number, and we write equals y. So a to the x equals y. All right, I'm going to leave the bottom two rules up here and show you just a few more examples of converting between these two forms. I want to give you guys several examples to practice. So let's start with exponential into logarithmic form. So say we have 3 squared equals 9, which is a true statement. We know that 3 squared equals 9. To change it to logarithmic form, using our log loop, we start with the base, which is 3, and that's the base in our logarithm. So log, and then we write base of 3. So that little number after the log. Then we loop around to the other side of the equal sign. So we loop over here to the 9, and that's the next number in our logarithmic form. And the next number after the base is our argument, that number in parentheses. So log base 3 of 9. And then once we get to the 9, we loop back around over the equal sign to the exponent, so to the last number we have. And when we close off our loop, when we finish that circle, we write equals and then the number we landed on. So log base 3 of 9 equals 2. And so if you type this in your calculator, it would still be a true statement. All we've done is rewritten in a different form. All right, now let's look at an example where we start with a logarithm and go to exponential form. So if we had log base 2 of 32 equals 5, we want to use our log loop to rewrite this logarithm in exponential form. So following our rule, we start at the base. So down here, this is our base is 2. And that is going to be the first number in our exponential form. The base in logarithm becomes the base in exponential form. So this 2 becomes the base, so we just write the 2. Next, we're going to loop around to the other side of the equal sign, and that 5 is the next number in our exponential form. So after our base, we have the exponent. So the 5 is going to be the exponent, so 2 to the 5th power. And then finally, once we've finished looping over to the 5, we loop back around to the last number. So we come back over the equal sign and finish with the 32. And once we've looped back to that last number, we write equals and then the number we ended on. So 2 to the 5th equals 32. And if you actually multiplied that out, that is a true statement. 2 times 2 times 2 times 2 times 2 is going to give you 32. So that's one way to check yourself. It may be a little harder to recognize it in exponential form, but you usually can tell, even just doing it by hand or using a calculator, if the exponential form is true. All right, so that is a little bit about logarithms and going back and forth between logarithms and exponential form. If you've got any questions, let me know. All right, you guys, make it a great day or not. The choice is yours.